Hi.
Yeah, thanks for coming on a weekend Saturday morning. I'm a JC teacher in Dunman High School. So I understand that some of you are from Singapore, but there are quite a few from other countries. So any of you are teachers? Okay, only from Singapore, and the rest, are you all familiar with the Singapore education system? No? Oh, okay. Oh, okay. So So anyway, we will talk a little bit about Dunman High School and some relation to the education system, and also the focus of today's talk is how we at Dunman High School actually conduct the A-level computing syllabus, right? And with a focus on hopefully developing good type of learners, right? But at the end of the day, we hope to get your feedback, right, to collectively shape the curriculum, right? So so the Singapore education system follows a 10-year compulsory education system. We have typically 6 years of primary schools and 4 years of secondary school, sometimes 5 years for some schools, after which they either get into a junior college, right, or they get into polytechnic, right? The polytechnic equips them for the industry after 3 years, right? They get a diploma, and the high school or the JC, the junior college, is more meant to prepare them directly for the university, right? So we happen to be a 6-year integrated program school, which means to say students after 4 years, instead of sitting for a national exam called the O-levels, they actually skip the O-levels and move directly up to the JC, right? So some schools in Singapore follow this system, and somehow, somewhere, someone decided that these are clearly students that are university bound, and therefore they hope that they will try to develop themselves in other areas, right, rather than sitting for 2 major exams in about 2 years, right? But ultimately, the JC students at the end of their 2-year course will sit for a national A-level exam and then hopefully move on to the university, right? So we have students from 13 to 18, which is equivalent to, I think, the US high school grade 7 to 12, right? Our school mission is to develop students' potential to the fullest, to enable them to care, serve, and lead. We actually have one ex-student here, Miss Heng. She's currently in SMU. Right? If you want to know more about Dunman High School, you can also approach her. Right. So this again a noble vision, right, to nurture leaders of honor who are high achieving, loyal citizens with a global outlook. Right. So for A-level, A-level computing is actually a subject that has been around for more than 20 years, right? But it has undergone a few revisions, right? So the latest syllabus started last year from 2012, and currently out of about 20 JCs, there are 4 of us offering the subject, right? So we hope there can be more, right? So what does the new syllabus look like? Right, you can just Google for it and you can get it from the SAB website. Right, so typically it focuses on computational thinking, right, which is pretty much some standard computer science introductory course objectives, and how they conduct the assessment will be they now sit for 2 papers instead of the previous 3. The first one is a net-based exam whereby they will answer about 4 practical tasks in one setting. Right? That's programming work. Right? After that, you also have another 3-hour written paper, right? Just like any A-level subject. Right? But the syllabus itself actually provide opportunities for the students to work on certain projects. Right? So in particular, there's an individual database project as well as a group web project. Right. So how we implement the subject in Dunman High, we tend to want to follow the spirit of the syllabus. Right. So there's this constructivism approach that says that at some point in time, when before they were textbooks, right? How do people learn about maths? Right. So before they were textbooks, people actually need some real world context, right, for them to learn about maths. So for example, say they are going to build a bridge, right, and this bridge they will need to figure out how much, what type of material, how much of it, at what angle, and therefore there are some mathematical concepts that later on gets translated to the different topics or disciplines, and therefore they are textbooks, right? But after that, this tends to be so-called taught in a very contextless way, right? So nowadays, people study trigonometry, people study algebra, but it's very difficult for them to apply what they study in real life, right? So we hope to follow the spirit of getting the students to build or make things, and in the process, learn about the theory of computing. Right. So whenever we come across a topic, we will always try to think about certain tasks that are related to real life, and if there is a way that it can be implemented or used, then there will be a good scenario for them to apply their learning. Right. So we have about 4.5 weeks of instruction time per week. So we see the students almost every day, right? So that provides quite a bit of opportunity for quite a lot of learning, right? This conference is about Python, so we'll zoom in. We use Python 3 for teaching and learning. The reason we do that is because we feel that it has a cleaner syntax. It's easier for students to pick up, and things are generally quite future-proof. Right. So, but we understand that there's still less support for certain libraries or frameworks. Right. So whenever the students get to do any web or cloud applications, things like App Engine, right? We actually get them to to use Python, but we don't teach Python 2 explicitly. It turns out that once the students know Python 3, it's not very difficult for them, right, to also learn about Python 2. Right? Most of the time they could just Google around and they will get the equivalent. Right? So to learn about web development, they also need to learn about certain frameworks. So we have previously explored CherryPy. It's a pretty good framework to use, pretty minimalistic, but we noticed that the development has not been pretty active lately. Right? So starting this year, we are also exploring Flask. Right? So both of them are rather equivalent, yeah, in terms of usage. Right? For App Engine, we started on App Engine because it is actually pretty easy to deploy. The students in Dunman High, all students and staff have Google Apps account, right? So that makes a lot of the API pretty developer friendly, right? The only thing we are a little hesitant about App Engine is that it doesn't quite support the relational database by default. Right? So there's a Cloud SQL equivalent, but to use that, the users have to actually register with their credit card, which is not what normal students will have. Right? So that's the reason why starting this year we actually move on to explore Python Anywhere. Right? And Python Anywhere also supports Python 3. Right? And the good thing is it allows support for relational database, which is what the App Engine doesn't quite use, except for the Cloud SQL part. But so generally, the syllabus actually has a section that only talks about relational database. Right? So we did some exploration, and we found that Python Anywhere supports Python 3 as well as MySQL and SQLite. Right? So it became quite a good choice to consider. However, because it's rather divorced from the App Engine, the Google APIs, so the students actually have to do extra work, for example, to perform user authentication. Right, so there are also restrictions for the free accounts. Right? So for example, you are not able to send emails programmatically. Right? So that causes quite some issue, because if, for example, if the user registers for an account, there is a user management system, but if the user forgets the password, right, there's no way for us to get him or her to reset, right, using email. Right, so these are some of the platforms that we explored, and the actual coverage is pretty much quite standard. Right, so this is almost what every introductory computer science course will cover. Okay, because of the web application requirement, we actually also get the students to do things like XML and JSON, right? And for some reason, there are some differences, right, in Python 2 and Python 3 usage. So we provided two versions, right, just to ease the learning effort. Right, so apart from that, we have fairly standard tasks. Right, so this is an example of an exercise on binary trees. Right, and because we actually have students that are quite high ability, so in general we also provide some challenge questions, right, for the stronger ones. Right, and this is another one on linked list, right, quite fundamental CS stuff. Okay, because of the emphasis on, or rather because of the requirement to do web application development, we actually also need to go into the web standards like HTML, CSS, and JavaScript. We generally the students are okay in picking up the basic usage, right? Even if you leave them to explore on their own. Right. Okay, we should show you some NAP examples. As mentioned, we try to link it as far as possible to some real life context, right? Even though some of them may be some simplified problems, right? So this is for them to validate a credit card, and the SingPost postal code. And yeah, we wanted to explore some big data stuff, right? So what we did was we actually got them to that was sometime in January, I think. There was this by-election going on, and we actually got them to try to simulate some data, and after that do some randomization and produce some results. Right. Then there's also some simple document analysis. We give them some mystery file. Right. It turns out that our students like to figure out some encryption or decryption stuff, right? So we give them some hints, right? And they actually are pretty engaged, right? Doing all the decryption, right? And then after that, to try to perform some basic analysis on the document after it's been deciphered, and this is more meant to be open-ended, right? So of course, most students will give the basic approach, try to find the highest occurring words, or some of them may go a step further to even try to pick up from some synonym libraries, right? or thesaurus. And there's also some compression stuff. I give them some sample files of different characteristics to try to compress and see which one of them can come up with the best compression. Right, there's also some fictitious library system, right, to implement some loan and return and fine processing. Right, some exam processing results, right, which is tied to their A-levels grading system. and some games leaderboard, right, that they have to manipulate. Okay, so we also try to, as far as possible, give them some context to apply their application development skills. Right. So, for example, the school has some online store, and basically is how we use Python Anywhere, right, to get them to implement this on online store. Right. So there is perhaps I can show you the demo. Yeah, just to skip ahead. Oops, sorry. Okay, so there's a JC1 student who used Python Anywhere, and what he did was, or rather she, right? Okay, you can actually browse the items, right? But you won't be able to order, right? Unless you're logged in. So once you're logged in, right? Yeah, the controls becomes enabled, and it's actually tied to some database, right? So this will dynamically change. Right, and after that, right, you can simulate some credit card validation, but this part is done using JavaScript. Right, so this is a typical project done in their first year after about 5 months. Okay, so how do we actually conduct lessons? We don't really give lectures, right? So most of the time, what they'll be doing is we'll just get them to follow what we type on screen, right? So so as we type out some simple examples, they'll try to follow, right? I think this is quite important because sometimes most of the time when people look at the learning materials, they probably already see what is a completed product, right? But they don't really get to learn about how is the solution developed, right? So we tend to try to get them to follow through, and also to build some muscle memory, right? As far as also, we try to link everything to the syllabus to Python, right? So even things that may not seem very Pythonizable, right? We will try to create some fictitious game, right? So at the end of the day, after this, they would have learned about the different type of number systems, right? This actually stands for decimal, binary, octal, hexadecimal, Unicode, and ASCII. Right? It's not very creative, but it's a bit weird. Okay, so we started with IDLE, and it is pretty lightweight, plain and simple. Most of our students still use that, but later on we also open up them to other IDEs. We tried using Eclipse for a short while, but it was rather heavyweight, right? And later on we came across PyCharms. Anyone here use PyCharms? Are you aware of that? Okay, it happens to be a pretty powerful and yet useful IDE for learning Python because firstly it supports autosave, right? And whenever you type, they will give you some hints, and after the thing is immediately saved, they actually automatically interpret the program for you. So if there's any errors, you are immediately alerted, and you can correct it on the spot, right? So you don't have to explicitly run the script and then look at the error message and then go back to your editor to rectify it again. And the good thing about it is it's also free for educational use. The developers are actually quite prompt and friendly, and once you submit a request, you get a response pretty quickly. Right. So we also tried to explore IDE 1, which is a cloud IDE. And the reason why we do that is because it actually has support for Python 3. Right. So quite frequently, right, the students will do it here, and after that we will get them to submit. Okay, so right, so you can also enter some input, right, if there is an input. Okay, so it gives you some error, and you can edit. Okay, sorry, I didn't save it. Okay, so what they do is that they will just copy and paste this URL, and then we can go to this page and look at their program and whether they have successfully gotten some output. Okay, we tend to explore things quite a little bit, right? So in the beginning, we actually use SyncPath, right? And then of course there's PySchools by Mr. Tan, right, for RP. And after that, when they did Google App Engine, right, after learning the standard documentation getting started guide, there's actually a course on Udacity, right, that allows them to pick up at their own time, right, how to do a simple block in App Engine. Right, then recently, of course, Code Academy also has a Python track, and unfortunately at that point in time, the students have already learned enough Python, right? So we just post them the link to get them to practice on their own if they are interested. Right, more recently, okay, traditionally we just have some Google Docs, and we share it with them, and we give them almost full editing rights, right, so they can do anything, right? But there's still an issue of getting them to go to a different environment, right, such as IDLE, right, to start typing their code and do things, right? So more recently, we have been exploring IPython, right, which you probably have come across, right? So it allows a rather unified environment, right, for people to actually try to run code, and yeah, we're trying to gradually migrate our materials to that. Right, but the concern is that currently IPython doesn't support input, right, the standard input, right. So that may be an issue because the A-level requirements require them to actually enter some data at the console or keyboard and then get the user to validate them.
So if you get the current master, they have no standard.
Oh, okay. Okay, thank you. Yeah, we'll try that. Okay. Okay, so why do we do things this way? We really want to nurture a new breed of students, not students that just study for the sake of exams, right? So there's this interesting book called World Class Learners, right? That defines intrapreneur and entrepreneur, right? So so to align with the school mission and vision, we want to really get the students to do their part for the community, right? So every one of them will have a GitHub account, right? So that's how they submit their work, and that's also how they collaborate and look at each other's work as a form of peer learning, right? Very much the first assignment that's given to them is about getting them to implement a web app for the school, right? Because we believe charity begins at home, and therefore we try to get them to do something that will be immediately useful to their classmates or their schoolmates. Right, so we show you a couple of examples. So for example, one student this on App Engine, right? Okay, so there's some graphing techniques that the students employ, right? But right, the app is actually smart enough. I'm actually intending to show you this, right? Because the app is actually smart enough to know that, oh, I'm a teacher, I'm a staff user, so I can't access this app, right? So that means the app is working, right? Okay, we will show you something that doesn't require login, right? So another student created this where is my future app, right? So if you enter the username, things are stored in some backend CSV file, right? So you can enter your results. Oops. Okay, so just maybe didn't do very well. Okay, so based on this, there is some processing, and they will compute the university admission score, and then after that, the system actually checks for the available courses that the students are eligible for. Okay, so beyond the school committee, after which we also like to expose them to the world, right? So we actually tried to encourage or motivate them to take part in Google Code-in, which is a high school open source involvement project, right? So we partner with some hosting organizations and to work on some open source projects. The task can range from simple documentation to writing code, right, or even doing testing. And through this, we actually receive some feedback that many of these organizations, they actually require the students to do some unit testing, right, which was not previously in the course. Right, but based on this feedback, we managed to incorporate it. Right, so also sometime last year, they do a group project, right, to try to apply some learning. Right, so it's a simple game to teach about some economic principles, and the students came up with some fictitious characters, and then based on certain decision, it will affect certain competitor action, right? And things are actually randomized, right? So okay, maybe we will skip it. Okay, so for now, this year, the good thing about this subject is pretty dynamic and live. So there are always opportunities every year, right? So we get to do new things. So this year, the students are taking part in some projects to develop some apps for the elderly, the elderly in the society. And then after that, we would also like them to explore code extreme apps, right, which this year focuses on a combination of hardware and software. Right. So there is really quite a lot of community support, right? So these are some of the resources that the students will make use of, right? And there's also this learning community, right, hackerspace, that we would like to expose the students to, right? So yeah, it's actually also the place where I learned a little about, in fact, it was actually the place where I got in touch with the Python user group in Singapore, and thereafter somehow submitted a proposal for this talk, and today I am here. Okay, so what are some of the issues that we face, like in a high school curriculum? There is always the tension between whether we should do things client-side or server-side. Python turns out to be an excellent choice of language for beginning students, right? But if you have to do some client-side stuff, things like validation or even Ajax, right, then the students actually would need to learn the right tool, right, for the right job, right? So so in so doing, we realized that JavaScript is actually quite difficult to digest for high school students. We haven't figured out how to ease the learning effort, right? And we also have students who right, spend a lot of time doing some right, some cool CSS effects, right? But they actually didn't spend too much time on the Python part, and therefore the front end is beautiful, but the back end doesn't work. Right. So given such constraints, we haven't struck a good balance, right? And also, the A level requires us to, I mean, the students are assessed based on mostly on first principles, rather than the use of built-in functions or modules and frameworks, right? So, for example, if there's a question on sort, right? It's typically perhaps a 5-mark question, and we can't expect the students to just use the built-in sort function and expect the 5 marks. Right? Even things like maximum and minimum, right? They will have to maybe run through a loop, right? To do that, right? So we are always aware that there's a lot of inadequacies, right, in what the students have created. For example, things like security, right, and scalability. Right? So we would like to have more time in addressing those issues, right? But perhaps given more time, when we become more efficient in our delivery, we'll be able to get to that. Right. We are also a little concerned about whether we should be teaching language independent stuff, or whether we should instead leverage on the Python philosophy. Right. So examples will be in classical computer science, if you need to swap 2 numbers, this is the way you do it. Right. But Python allows you to, in a single line, do the magic. Right. And of course, Python by itself doesn't quite support encapsulation in OOP, but the syllabus requires the students to understand and give examples of encapsulation. Right. So we had to, in a way, tweak it somehow. Right. But of course, so that for example, this example, we will put a double underscore and set pretend that it's private, right? But we know that nothing is private in Python. But somehow, by tweaking this a bit, it gives you some error, and we say that, oh, this shows encapsulation. Right, but of course, Guido doesn't buy that. Right, but at the end of the day, we do teach them the correct stuff. I mean, we do try to tell them that, oh, in Python, this is really the way how you should do things. Right. So for the past couple of years, there's some. Oh, okay, sorry. Some recent movement and internationally, and we know that, oh, there's a lot of voices advocating the study of computing or programming at the high school level, or even at the primary school level. Right. Okay. So lastly, yeah, we like to invite some feedback. We know that there is always there's always a disconnect somehow between academia and industry, right? So, but we really hope that you could help us shape the curriculum. The curriculum has a 6-year cycle, so next year is the 3rd year, and there is a mid-cycle review. Right, so we would like to receive some feedback on how we can improve the state of affairs, and we want it to be connected, but we don't want it to be too like, for example, a maths subject. So for example, when we hear from the university, they say, oh, the students should do more maths. Right? But we don't want a maths subject, because at A level, the students are already doing a maths subject. Right? So we also want to find out how to improve the participation rate for girls. Like somehow it goes up and down, and we don't know how. Right? Maybe you can have some insights. Right? There are things that we are defined by things that we do, and we are also defined by things that we do not do. Right? So as far as possible, we will. We have tended to move away from desktop apps, right? Because we believe that web apps should be the way to ensure a greater outreach. Right? So possible directions could be this, and we really want some meaningful distractions because our students are distracted anyway. Right? Every day they get crushed by candies, and for some reason, if you can't beat them, you join them, and you want to distract them, but in a more meaningful way. Okay, so this is some idea. We were hoping that there can be some translator to convert from back end to front end to ease the development effort, because the students actually now spend quite a bit of time on doing the HTML side and CSS side. Right? But hopefully some of you developers out there can point the way. Okay, so yeah, so are we doing too much, not enough? And given a diverse group of students and understanding that how can we cater to the high school context. Okay, so there's this story by Confucius. Zilu is a disciple of Confucius, right? And one day he somehow someone knows that Confucius is doing something that is rather impossible. Okay, so we end with this, and we invite Q&A. If you have any input or suggestions or feedback. If not, we are always open. Thank you so much for your time.
So any questions from the audience? Yeah.
Very quick. So what we know, so I'm a physicist. So what we notice often is that yes, they can build the students can build like websites and stuff, but they hardly have an understanding of how a computer works anymore. So have you considered like the Raspberry Pi or something, where I think typically undergrads, they find it super cool to work with, and at least you understand how a computer works, because like people now can build all fancy stuff on a web app, but if you ask them, to actually implement something more technical, they're completely lost.
Yes. We are trying to explore that actually this year. So as I mentioned, there's a Raspberry Pi, and for Code Extreme. Right, so we're trying to get our students involved in that to learn about. The previous syllabus actually has some parts that are related to hardware, right? But the new syllabus has taken them out because we felt that somehow the committee felt that it's too content heavy, and we should teach problem solving and computational thinking skills rather than just content or facts. Right? But I think it's a good way to get the students to also learn about hardware and engineering. Right? So this year we're trying to expose our students to that.
My comment was more tailored towards it's nice to know all these abstractions. Like it's good if they can use Cherry Pie, but if they have no clue what the computer is actually doing, it's actually quite hard sometimes to get away from those abstractions. So, and I mean I'm pretty sure like somebody came up with the syllabus, but I wouldn't have put web development in computer science one.
Okay. I think basically the philosophy or the thinking behind is that we want to excite the students in creating or making things, but through the process, just like the constructivist approach, we want them to, through the process of building things, appreciate the underlying computing concepts, which will be delivered when we go through their projects or assessment.
Do the students work individually or do the students work in small groups?
There are individual projects, there are also group projects. Right? So a group size is typically between 2 to 3 usually, sometimes very rarely up to 5. Yeah. So at some point in time, they also learn about pair programming. Like one serving as a coder and the other one as a reviewer.
So do most of the learning take place in like a controlled environment within classrooms? So do you like often bring them out, check out the industry, how most of the companies
okay, we most of the learning happens in the classroom, but as I said, in a more hands-on setting. Of course, a lot of learning also happens outside the classroom when the students are working on their projects. You can ask Ms. Heng. Right, and there's also a lot of self-learning involved. And starting this year, we also tried to expose the students, like we mentioned that there's this hacker space, and we got some students to attend Sayanese CSS3 workshop.
Another question, do you teach them some basic system analysis skills to analyze a project, for example?
Yes. In fact, the syllabus has where is the syllabus? The syllabus has a part on project management, which includes software engineering. Right. So the students are supposed to perhaps behave like a project manager and try to understand the different phases and processes and tools and techniques that are involved.
Is there a place for graphical programming languages like App Inventor?
Okay, we actually tried to do that in our Sec 1 curriculum, not at the A-level curriculum, because I think at A-level, somehow the students already have the majority level to think about abstraction. So they don't really quite require a lot of visual aids. I mean, that's so far from our limited experience, but in addition, we actually don't really have a lot of time in the curriculum to go into other tools. But at the end of the day, at the end of the first year, their end of year project, a lot of them actually move into mobile apps, or sometimes even native app, and they have to actually pick up another language such as Java or Objective-C. And we actually have a few students who, after deciding that Android is too much for them, move on to App Inventor, and they created an app and deployed it to the Play Store using App Inventor. Right? But at that point in time, they would supposedly have all the necessary computational thinking skills and knowledge, right, to do it themselves. Right? The syllabus does not explicitly require them. Yeah, but any curriculum can be adapted or can be personalized to individual institutional needs. Right? This is just how we choose to do it.
Any more questions? One more. One last question. Stop soon.
Okay. Just want to know about your students, right? So I have two questions basically. After you basically show them the theory of CS and also how to practice them on Python, and my first question is, do they become more interested on the theory, or do they become more interested on actually seeing the results, like creating an app, for example, with Python, the practical results? That's the first question. My second question is, after they've gone through this course, how much of them actually want to take this up as a career?
Okay. Okay. The first question is so I can. Okay. Actually, the students are generally more interested in building and developing things, right? So, but it's actually quite important that at the end of the day, because they have to take a high-stake A-level exam, to bring them back to the underlying concepts, and it's something that we would need extra traditional exam techniques and drilling skills to get them to lay out their understanding in a form that is exam ready. Right? We can't say anything about the new syllabus for your second question because the students have not graduated. They are now in JC2. But from our previous syllabus, we do have quite a sizable number of students who, after taking A-level computing, move on to take a computing-related course in the universities. And because of this, we are trying to increase the enrollment, not only in Dunman High, but hopefully in other junior colleges. Right? Because if you have more people, then probably there will be more computer science students. Okay. Okay, so sorry, thank you so much. Yeah.
Thank Mr. G for his
Thank you so much for coming.
teaching in Singapore.
Yeah.
And this is a token of appreciation from us.